Today we're going to talk about scatter plots. So scatter plots are graphs that are used to measure relationship between two data sets or two variables. And these are used to show possible trends that may be occurring. And there are three types of relationships that you can look at a graph, a scatter plot graph, and be able to see if there's any kind of relationship. We call those relationships correlation. And correlation is how closely two variables are related. It's not necessarily a cause and effect, but a lot of times people tend to lean that way. So correlation is just the relationship they have. One may be a predictor of the other, but not necessarily. So here's our examples here. We can have a positive correlation. So in this first one, the auto insurance cost, notice that it increases as auto accidents increase. So when we see something where two things are actually increasing as X goes up, so does the Y. So that's how we have this positive correlation. All these little dots that you see, they're really close together. Now all the dots are not going to be perfect on the line, but this line fits them as a kind of a trend, or a kind of a trend line fits in the kind of the middle of them. So this is a positive correlation. You see this when one variable increases and the other variable increases. And you can see that the variables have the same trend. So it's not necessarily if our Y is increasing, our X is increasing, going up, then our Y is increasing. We could also think if our Y is decreasing, our X is decreasing. Those are positive relationships. Okay, so even though you have, don't always think that it's going to be X increasing and Y increasing. Then our next kind is a negative correlation. Notice we have auto values and auto mileage. So the auto mileage, when it's up, we can think about it's like if we look at this little point right here, the auto mileage is up here high, but the auto value is down. And when we kind of continue on, as the auto mileage goes down, the auto value is up further. So the more mileage that a car has, then the less that it's worth. That makes sense to most people unless it's a classic car. So as one variable increases, the other variable decreases. So you can think of this way. If X is going down, Y would be going up. Or if X is going up, Y would be going down. So you can remember that negative, just like when we learned slope. This is a negative slope. It's a negative correlation. Just as positive, that's a positive slope. It's a positive correlation. Notice too on these, all the little dots, they're not perfectly on the line. It's this line is a trend line. It's a line of best fit. We'll talk about how to create those lines to see how it kind of fits the data. Our third type of relationship is a zero or no correlation. Notice that we have auto body color, and it's being the relationship that's compared to is auto quality. The color of a car has no bearing on the quality of the car or how well the car runs. You've seen some older cars that may look really dingy and they still run, where you might see a brand new car that's beautiful, bright cherry red on the side of the road. It has no correlation. And you can see the dots are all spread out everywhere. There's no way to fit a line that would get them all in a certain trend, so this is a no correlation. So there's no relationship between the variables. All right, so let's look at some other things that will help us tell about the strength of a relationship. So strength of relationships can be measured as strong, moderate, or weak. And we use something called the correlation coefficient. And it's abbreviated with a little r. And that's a number that is between -1 and 1 that tells us how strong the correlation is. So the closer it is to 1 or -1, the stronger the correlation. The closer it is to 0, the weaker the correlation. So here's kind of a little scale. So if we have a R value or correlation coefficient value of 0, that's going to give us something that's all scattered. So if you have a think about what it would look like here. It's all scattered around. There's no linear relationship. We can't see anything. Whereas if we move to the ones and we move away to the -1, you'll notice that what our graphs look like. So this is a correlation coefficient of -1, and this is as a +1. It's still a very strong, it's almost like a perfect straight line. So it's very, very strong. -1 is very, very strong, almost perfect straight line. The only difference is the negative shows that this is a negative correlation, and the positive shows it's positive correlation. So that can kind of help us know what's going on there. Where we have in between here 5 to 8 or 0.5 to 8 for the negative side, same thing, we can see that those are a little bit more scattered, but we still could make a line that kind of fits that data. Then when we get down to between 0.5 and 0.2, so example this one and this one, they're a little bit more scattered out, but we still could get a line that kind of fits most of the data, but it's very weak. It's more spread out. So those things help us tell about the strength of the relationship. Now, here's some examples we're going to talk about and see if we can determine if they're, what type of correlation they have, positive, negative, or no, and then we'll look at some R values. So the amount of time spent exercising and the number of calories burned. So if we think about that on a graph, if we're exercising, so time exercising and calories burned, well, we think about that, the more we exercise, the longer we have more calories that are burned. So that is a positive correlation. Amount of time spent exercising and your weight. So the more we exercise, think about what your weight would do. Hopefully, if we're still eating right, because that's a big factor, if we're exercising more, so our exercise goes up, our weight would go down. If we're exercising less, usually our weight goes up because we're not doing as much and we start gaining weight. So these are opposites when one's going up and the other one's going down. That tells us this is a negative correlation. Amount of time spent exercising and hair length. Well, I can spend a whole bunch of time exercising, but that does not make my hair grow. It does not make my hair shorter. So these are no correlation. So now let's look at some R values and see if we can match them up. So age of several toddlers and their weight. So if we think about a bunch of toddlers and how much they weigh, all toddlers don't weigh the exact same. But usually, if we're talking about toddlers, we're talking about between 1 and 3 years old, there's a scale that they all are on. If someone's very overweight, then they're going to kind of be an outlier. Or if they're very underweight, they're going to be an outlier. But most of them are kind of within that same trend. We can see as they age, so several toddlers as they get older, their weight's going to go up some. So we got two things rising, going the same direction. X is increasing as Y is increasing. So it's not a perfect, because we know there's some outliers and not everybody's exactly, it's not going to be perfectly linear. So we know it's not going to be a negative correlation because they're both going up. So we know it's going to be a positive. So we're thinking a pretty strong here. So number 1 would match with C. All right, let's look at number 2. Number of hours driving. So if we drive a lot, so think about it increasing. And distance from destination. Well, if I'm at home and I drive a lot, I'm going to be further away from from my home. So we can think about I'm driving and the distance that I'm getting to my destination is actually getting closer. So it's going down. If I'm going to the beach, the more I drive away from my house, the closer the beach gets. So I am having two opposites. So I know that this here is going to give me a negative correlation. So I know it's going to be negative. So the only options I have are the negative 0.04, which is very, very weak, which means there will probably be almost no correlation, or the negative 0.9. So the best answer for this one is D. Number 3, outdoor temperatures. Okay, so let's think about the outdoor temperature. As the outdoor temperature increases, number of short sleeve t-shirts increase. Yeah, they do. And so, but just because the weather got a little higher, does that mean everybody goes out and buys a t-shirt? No, most people have their own t-shirts already. Now, if they said number of t-shirts worn, that might be a little bit different correlation. But it is a positive correlation, but it's not necessarily a strong one because not everybody's going to go out just because the temperature rises to buy a t-shirt. So the best match for this one is B. And the last one, kind of by elimination, we are going to know what this one is, but the birth month and the current grade in class. So if we think about that, the birth month that we have, say March, and the grade I am in class. Well, some of you have March birthdays and you're in school, and some of you have, maybe your friends have March birthdays and they're out of school, like because they've graduated, or maybe your younger siblings, or maybe your teachers. So just because you have a birth month doesn't mean what grades you're going to be in math class, or your current grade in math class. At 80, you may not even be taking math. You might be a grown-up and not taking math. So this is a no correlation. So it doesn't match any of those. All right, so now we're going to talk about regression. Regression is a function that we use to fit data. So when we have all these scattered data plots, we want to try to find a line, an equation, and that's called a regression line. It's actually called a linear regression line, and they're used to predict what will happen in the future for a certain trend. So these are used a lot in all kinds of situations in the world to see kind of what will happen in the future. We can call this the line of best fit. That's what's used a lot in language and mathematics, or linear regression equation. All we're doing is we're going to make a line that fits the data best. So when we were looking at those graphs earlier with all the little dots on them and had that line drawn through them, we're going to make an equation for those lines. Now, I've added some stuff how to do this on a calculator, a handheld calculator, but I'm actually going to show you how to do this on Desmos because it's so much easier and there's less steps to have to remember. So if you want to try the handheld one, the directions are here. There are also some more directions at the bottom of the notes for the handheld calculator as well. So we're going to look at this example here. The table shows a relationship between calories and fat grams contained in hamburgers from various restaurants. So we have our fat grams, 28, and the calories for that hamburger would be 305, and then 34 and 410, and so forth. So these are different restaurants with different fat grams and calories. And we want to see, is there a correlation between the number of fat grams that's in something and how many calories it has? Now, if I think kind of realistically, if the more fat I eat, I would think I would have more calories coming out. So I'm thinking it's probably going to be a positive correlation. I don't know how strong it's going to be. I think maybe a little bit strong. But this is going to help you find the equation. So we're going to use Desmos. And I've already pre-pulled my data in. So I went ahead and put my data that we had from the notes here into a table. Remember to do that, I just hit the plus in Desmos and a table, and then I can add my values. Now, anytime we're trying to find a line of best fit, we want that in y equals mx plus b form. That's the linear equation form. For Desmos, whatever is in our table here, like the x1, has to be a little subscript 1, and the y1 has to be a little subscript 1. So we're going to put that in our table, and then on our next one, what we do, so you can kind of see our data here and the little green dots there, it looks pretty positive, like it's increasing positively, and it looks pretty tight together, so it's probably going to be a pretty strong correlation. So on the next line, I can put in that y1 and that little abrev. It looks like a little I don't know, minata kind of thing, and mx1 plus b. That's what I put into Desmos. And that y1 and x1 has to match whatever's in my table. And so now I'm going to just put it in. It's going to give me all the information I need. So you'll notice it gives us the m, and it tells us it's 13.9542. So now I know, so let me erase here so I have some room to write. All right, so I'll just write over to the side. I'm not having a whole lot of luck with my erasing here. So I'm going to have y equals, look at my m, 13 point, and it says 3 decimal places, so I'm going to round 13.954. X, that's my slope, and then my b is negative 76.55, it'll be 6. So negative 76.556. That would be my equation. Now, it says how well does it fit through the data points? So if we look and see, when it asks how well, we're not saying, yeah, it fits pretty good. We obviously want to look at that, but if we turn this on and we look at our data, we notice that it goes right through the points. So it's fitting very strong through the points. It's a positive correlation, so we know it's a strong positive. But what they're asking is, what exactly is our R value? How tight, how strong is that relationship? So you'll notice on Desmos, you have an R squared. That's not what we're looking for. We're looking for just the R. Our R value, which is our correlation coefficient, is 0.9938. That's pretty strong correlation there. And we could round that to 0.994 as well. So it's very, very strong. Almost a 1, not quite. It's not a perfect correlation, but it's pretty strong. Then it says, predict the number of calories that are in a burger with 50 grams of fat. Well, if we know that our X is our fat, and we now have our equation, we can plug in to our equation. Instead of X, we'll plug in 50. And then you can use your calculator. Now on Desmos, because you already have all this in, you can actually go to the table and on another line, just type in 50. So we're going to type in 50 and we can see what would actually work. Now, we have to get it to calculate for us, we would have to take up here at the Y1 and we would have to change that to our equation. So we'd have to change it to what we had on there. Now, this you could just plug in a calculator or on another line. So let me delete this one and we'll go to another line and we'll just put in Y equals, and we're going to put in our number 13.954, use our parentheses, and we're putting in 50, close our parentheses, minus 76.556, and it tells us that would have 621 calories and a little extra. So about 621 calories. Now, the next question says, predict the number of fat grams that a burger would have with 760.7 calories. So we don't know what the X is, but we know what the Y is. So we can use the same one. We're going to delete there and put an X back. And now instead of being equal to Y, it's equal to the 760.7. And we can kind of see where that would go. We could use it on the graph. We also could use algebra to solve. Now, so when I solve that equation mathematically, I'm going to get 60. That would have 60 grams of fat, which is a lot, but that's a lot of calories for that burger as well. All right, so let's look at our other example down here. So example 2 shows a table that has numbers of members in a club since 1995. Now with years, you have to think about changing them. If you put 1995 into Desmos or into a calculator, it's going to calculate it as 1,995, not as a year. So we're going to think about our very first year as being year 0. And then progressively year 1, year 2, 3, 4, and so forth. So I have marked out our years here and put 0, 96 would be 1, 99 would be 4, and 2001 would be 6, and then 2003 would be 8. And so when I put those in my calculator, so I've already done so here. Let me turn my other ones off so we don't see that. So let's turn these little dots on. And I now notice, because I put this table in after I put the first one in, these are X2 and Y2. So in my line of best fit, or my linear regression equation, I have to put in Y2, X2 to get it to plot. So you can see it does plot right on top, pretty strong correlation. And when we look and see what our numbers are, we see our M, or our slope, is negative 12.0402. And our B is 93.3527. So let's make our equation. This is round to 2 decimal places, so we're going to do that to 2. So Y equals negative 12.04x, and then plus 93.35. So there would be your equation. Then it asks, how well does it fit the data? Well, it fits pretty strongly, And we can see by the way the line looks, it's negative. So we know it's a negative correlation. So we know it's pretty strong. Not maybe as strong as the other because there's a little bit of a dot kind of hanging out. It's strong, but it's a negative, and it really wants to know our R value. So our R, our correlation coefficient, is listed for us. R is negative 0.89. And I just rounded 2 decimal places. So it's pretty strong, but that negative in front of that 0.89 tells us that it's a negative correlation. Now, we're going to use the line of best fit to predict the number of members in 2000. So remember, 2000 was the year. If we look back at our table, 2001 was 6, so 2000 would be 5. So we'd actually plug in 5 in for our x and solve. And we plug that in, we would have negative 12.04 times 5 plus the 93.35 is equal to y. And when we use our calculator, we could get the solution for that, and you would solve for that. So you could predict what it is. So these lines of best fit or linear regression lines help you to predict what is going to occur. So at the bottom here, we have calculator, how to use the calculator. When you use the handheld calculator, you have to have the diagnostic on to be able to see the R. And so this tells you how to get that on and how to put in your data. But honestly, because the Desmos is so user-friendly and it takes very little time to put things in and to see any mistakes, I would really suggest you use Desmos for this. It helps. It's on the state test, and you don't have to remember about turning all these things on. But we will go over how to use the calculator if you desire to really know and you need help with the instructions.